Welcome back to our Unity tutorial mini-series. Today we're going to go into our next part, which is optimizing our raycast controls to work with other areas to make our game look better. So first of all, let's open it up. And once we're in, I'm just going to quickly load up the scripts while I'm talking. So the first thing you'll notice right away is that this looks very different than the original Unity project. So back in the workshop, we added a couple enemies and we improved player controls. So I encourage you to watch the workshop video if you haven't already. It should be the one right before this one, and it should say workshop. Essentially, this uh, this platformer has been adjusted so that we have more platforms, and the scripts have been improved as well. You'll notice that the platforms are placed under this platforms game object. The enemies are placed under the enemy game object. We actually implemented a flying enemy, which works the same way as the regular enemy, but moves up and down. And due to how we optimized scripts and stuff, it's not gonna look exactly the same. So I encourage you to just use the Unity package that we've provided in the link in the description below. It should be on the GitHub. All the files are on the GitHub, so you don't have to worry at all. You'll notice right away also that there are 4 scripts, when originally I believe there's the raycast detection was named something else, and the names have been changed as well. So if you look into all of these, player input, enemy movement, raycast detection, and player manager. So first off, let me start with the player manager. You can see right away it doesn't really have anything in it other than the variables, and that's because the player input inherits from the player manager. So the player input is a player manager object, which means that all these variables will be present. If you click on the player and look at the player input, you'll see all the variables. And I've divided it with certain spacing and headers, which you can do yourself if you want, and you can rename these to whatever you want. But if you look, they should be divided that way. Another thing that has changed is regions. So you can highlight certain areas by typing hashtag region and then naming the region what you want, and then ending it where you want. And you'll see that as soon as you do that, you'll have this sort of minus sign, and you will be able to collapse. Speaking of which, in scripts, I noticed that the font size was a little small last time, and people were asking if I could just get that to be a little bit bigger. So I'll make it about 14. Hopefully that's clear enough. Either way, you can collapse regions like this. So I did that for player input as well as raycast detection. You'll see this way more in raycast detection because there's a lot of different things, like structs are all in this region, calculations are all in this region, raycast variables are all in this region, collisions, and then finally I made this new part called getters, which essentially allows you to access if you're grounded, right, left, or above in the other scripts. So it'll be able to tell you your your different collisions in the player input script so that you can understand how to do things like coyote time and other things that we implemented in the workshop. So as you can see, reidetect.get below will get the grounded thing. So we'll check if there's any collisions below you, which is what determines if you're grounded. So essentially, all this stuff I've set up so that we don't have to go through the deep details because it's essentially the workshop, but condensed and improved and optimized. So I really strongly encourage you going through that. There's one other thing that you might notice. This is protected instead of private. And what that essentially means is that whatever inherits from that, so player input inherits from player manager, that means player input can just access these variables without having to do some extra stuff to get those variables. So I can straight up, if you see in here, gravity, I can just access gravity. Oh, sorry, not gravity. What's something that jump height, right? I can just use the jump height right away to determine the jump gravity. And these never have to be accessed by the player, so these don't need to be shown in the inspector. These are just variables that we use in the script to determine those things. So these never have to change. So these are the variables you might want to adjust. So if you look at my player, I've set him up accordingly with 10 movement speed, 5 jump height, 0.5 jump time. I implemented something called max health, which we have not which is not used in the scripts yet. So we're going to go into that today. Jump damp, it's how much you want to jump once you release. So 0.5 means as soon as you release, you do like half the amount of jump. So that gives you a variable jump from half to the full height. The fall multiplier is how much faster you want to fall. I don't like the feeling of being very heavy in my game, so I decided to do 1. But if you want to multiply and make it like 3 or something like that, 3 times your weight, then you can do that. And I set up this range so it hits from 1 to 3, but you can always adjust the range in the script itself. See, the range is from 1 to 3. And then the total jumps is how many jumps you can do. You can do, if you put 2, you can do double jumps. I put 1 because I want a single jump. I don't like having too many jumps. It feels cheap to me. Coyote time is the amount of time that you have until you can jump after you're off a platform. So in 0.1 of a second after you leave the platform, you're still able to press jump and you're still able to jump even though you're not touching. Then jump buffer time is before you land, if you press 0.1 of a second before, then you still feel like you've pressed the button. And this wasn't covered in the workshop, but it's essentially the same thing as coyote time but reversed. And then allow jump from fall. This thing is once you fall off, sometimes some games don't allow you to jump because they only want you to jump right before you fall. So I unchecked that because I do not want to allow the jump as you fall. I want you to be forced to jump, and if you fall, you just fall. Essentially, that's how I set it up. After the player input variables, something else that we can look at is the layers and tags. So right away, you'll notice that there's multiple tags: player, enemy, flying enemy, and platform. So I set those up just because it'll be useful in the script, and then the layers: player, platform, and enemy. So try to make sure that all your platforms are on the platform tag and layered on the platform, and then the enemies are labeled accordingly. So the flying enemy will move up and down. The regular enemy move left and right. So they're both on the enemy layer, but they each have their own tag: flying enemy and enemy. So make sure you have those tags so that the scripts can work. And That should be it. Oh, there is one thing in the raycast detection script on the enemies and the player, because they have to be able to detect each other, right? The player has a layer mask. Originally it was just platform. You might want to select enemy if it's not already selected, so that the player can collide with the enemy. And you want to do the same thing for the enemies as well. They want to collide with both the platforms and the player. And that should be the preliminary setup that you need. And if I just run this, you can see there's collisions with the player, the enemy. They move up and down, and it works for the most part. So now let's do what we actually wanted to do all along, which is implement health. So you'll see that this max health variable is there, and if you actually go into player input, there's this float health as well, but it's grayed out because it's not really being used. So that's generally Unity's way to show that it's not being used. So first off, in the start method, what we want to do is set the health to our max health. So the reason I set it to be 1 is because I want insta-death. If you touch the enemy or the enemy touches you, then you get harmed and you die. And it's essentially like that bullet hell type of experience that you'd want to have, where you don't want to touch any enemy or like any spikes or something like that. And this is just a simple way to implement it. You could add more health if you wanted to, but ultimately I decided this was probably the best way to teach the tutorial. So if we set the health to equal our max health, that should be good enough for our start method. In the update method, we want to check our health, and if it's ever below 0, we'll eliminate it. So we don't have anything called check health right now. So we're going to make a new method, and we're going to name it public void check health. So in check health, what you want is to see if the health is less than or equal to 0. And if so, we want our health to be set back to max health, and we want to respawn. So how would we respawn? Well, let's create another method called respawn, and all that's going to do is it's going to reload the scene. So before we actually do anything, we're going to go to the top and say using Unity engine. So we already see this using Unity engine. Now you need the dot and then scene management. So it should show up, and using Unity engine dot scene management. The reason we want that is because it reloads the scene when we need that. So over here, what we're going to do is say scene manager dot load scene, and then in parentheses, we want to do scene manager dot get active scene. So that'll give us the active scene that we're at, and then we want to do dot build index. So what this is saying is it's gonna get our active scene, it's gonna get what the number of the active scene is, and this takes in a numbers to reload that scene. So that's all we're doing. And that should work if our health is less than or equal to 0. The reason I don't want to, or actually, I could set it to 0 to start with. No, if the max health is set to 0, then it's messed up. So, yeah. So I'll implement the other parts first then. What we can do now is actually go to raycastdetection.cs. Let's close this getters region and open up collisions. under collisions, you'll see all these various things. So let's go to ground check first, and let's write the code in there. Oh, before we do that, let's first create a new variable. So this isn't really a raycast variable, but we're gonna call it a public static float hurt player. So a public static float is something that you can access throughout anywhere. And honestly, I could technically put it in player input, but I want to use it just here, so I'm just going to leave it here. And you might ask, why are you making it public? Well, I want all the scripts to be able to access that. And I guess if somebody really wanted to mess up your game, they could do something where they affect this variable and it will hurt your player more, but harming your player is not really something that most players look to hack for. They want to help. I mean, I guess if you set it to negative, you could do that, but I have a workaround for that, so I'll show you in a second. So hurt player, and then once we go down to collisions, we will say if the transform dot tag dot equals our player. That's why the tag is important. We need the tag set, and what else? The hit dot transform. So if we're the player and we hit oh wait, we have to say hit dot transform dot tag dot equals the enemy or the flying enemy. So I'm just gonna copy paste that and rename this to flying enemy. If one of those happens, so you don't want this to work with the and first and then check the or. You want to check or first. So if it hits one of these guys, there we go. It should be the right number of parentheses. If this happens, then we want to hurt the player by 1. So essentially, once we have that, we can actually copy this and paste it right below and actually change it so that if the hit dot transform equals player and the transform either equals the enemy or the flying enemy. So essentially what this is saying is if the player hits the enemy, then we want to hurt the player. And now this is saying if the player is hit by the enemy, then we want to hurt the player. Either way, we want to hurt the player. So if any contact is made with the enemy, we're hurting the player. This isn't like Mario where you're jumping on a Goomba. I mean, you could implement that using similar logic to this and making enemy health and stuff like that, but I want to keep it simple so that you just hurt the player either way, so he tries to dodge the enemies more so than land on the enemies or do other stuff. Okay, so now that we've got this implemented, we can save that and then go to player input. And over here, we can actually set if the health is less than or equal to 0 by saying health minus equals raycast detection dot hurt player. Now, somebody who's a hacker who has access to this can say, oh, what if we make this negative? So subtracting a negative would actually give you health. So that would actually be annoying. So something we can do is mathf.absolute value. So if they made this negative, it would just become positive again. So you don't really have to do this because nobody's really gonna want to hack your game, and if they do, it's like a single player game, so it's not really something that you have to worry about, but I mean, if you want to. Once you hurt the player and subtract that amount, right? So max health is 1, so in this case you would just kill the player, so this would run and you would respawn. But we do want to set the raycast detection hurt player back to 0 right after doing that, or else it'll keep respawning infinitely because it's not set back to 0. So it'll keep subtracting 1 each time, and you'll keep respawning every frame, which will literally crash Unity, you know? So we don't want to do that. Now that that's there, we should be... Oh, I did make a mistake, actually. This is checking if you're touching from the bottom. If you're touching from the left, the right, the top, it's not going to hurt your character. So we want to copy this, and we want to paste this in every region. Both the left, the right, the top, and the down. Inside if hit. So inside there, you want to do that, so it checks all this. Now that we got that, it should work seamlessly. Oh, there's one last thing that we have to do now. We have to go to File, Build Settings. And the reason we go to Build Settings is because we want to check if our scenes, platformer scene is there. If not, you can just go to Scenes and drag it in. Either way, this is the build index, so it will look at the build index and reload that scene every time. So don't build it and don't build and run. Like, we're testing right now, so we don't actually have to build the project. But essentially, now if you land on the enemy, you will die and it will reload the scene. So don't land on the enemy, don't try to get hit by the enemy. There you go. So I'll put the player above this platform so you don't have to keep moving right as the game starts. So now that we've got health working, one thing that we want to do is implement a moving camera, because you can see we have this big level, but if we see our player is just this area, and if in fact we make the camera a little bit smaller, kind of move it, or we don't have to move it yet, we can just leave it where it is. If we make the camera smaller, right, our player might go here, and oh, you've lost him. Where is he? Oh, he's still there in the scene, but the camera is not able to see him. So we want the camera to follow the player. Now, what some people just do is just they put the camera under the player, and essentially what it would do is it would follow the player no matter where he is. But it's like so rudimentary, and it's not great. The player has to be centered at the starting for that to happen, and it's just not the best way to implement it. And making your own script is also a little painful, so why reinvent the wheel? What I've found is to use something called Unity Cinemachine. So if you go to Window and Package Manager, you'll see the packages in project. It should load a little bit. Okay. So under packages in project, instead you want to go to the Unity registry, and under there should be Cinemachine. So you don't want to be in your project, you want to be under Unity registry. So once you go in here and you get that, you can just install Cinemachine. So what's cool is it has a camera controller and it will do everything for you. You don't have to worry about anything except the settings. So once we have that, and it compiles all the C# scripts, now we just wait. Okay, now that we're back, we can just go to Cinemachine. You'll see now that there's this new thing called Cinemachine. And if you see the list right here, at the bottom is something called Create 2D Camera. You can just create it. It says CMVCam, so it's kind of strange, so we'll rename this to Player Cam. Do not delete your main camera, because what it's doing is it's using your main camera to simulate things, and it's just useful. So keep this right under your camera, and they'll be right next to each other. What are you following? Well, you can just drag in the player, and once you get the player, it'll center right on him right away. And now if you just play with it, it should already be far smoother than what you're used to. My computer's laggy, so because it's recording as well, so it might not look as smooth, but essentially you can see it's like lerping towards it, which means it's like smoothly moving to it. He might be off center for a second, but it will recenter towards him. It's really cool. So right off the bat, in the player cam, we can adjust some things here. Look ahead time, we can make like around 0.5. Let me just set it manually. 0.5, look ahead, smoothing. You can do something like 5. Look ahead, ignore Y. We can ignore the Y direction. So essentially, when it allows the player to move around wherever you need to, we can leave this stuff alone. Dead zone. This will give you, okay. I don't know why I can't see. Oh. I know why. The gaming window guides are off. So make sure this is on and you'll be able to see a lot more. Okay, so dead zone width is about how much you can travel without the camera having to move. So I keep it fairly small, something like 0.1 should be sufficient. And the height would be something like 0.05. And essentially in the small space, the camera will not move. But if you start heading out of the space, then the camera will move a little bit with you. And I do not want to center on activate, because we can just test this out, and you'll see this is the point that the camera follows, and we don't need to center right away. If you're looking ahead, you'll see a little bit ahead. If you're looking behind, you'll see a little bit behind. Sorry, if you're looking ahead, yeah, the camera will be more in front of you. And if you're looking behind, the camera will be more behind you. And that's usually how games work. So it's really useful. So, and you can turn this off by turning off game window guides, like I said before. So yeah, that should be good for the settings for the camera movement. So now you have a moving camera. Everything's working. Now let's get some moving platforms in there. Why not? So first of all, let's make a new script. And call it platform movement. We already have enemy movement, so we can pretty much copy paste and yoink this stuff. Control A, Control C. And then if we just open up the platform movement, you can just do Control A, delete all of that, and then Control V to paste. And then just change the name from enemy movement to platform movement. And all the red highlights should go away. You don't need gravity anymore, because moving platforms usually don't operate with gravity. You can remove that entirely. The enemy move speed, you can right click and rename it and name it platform speed. What else? You have the velocity, the ray detect, move direction. All that stuff is useful. Oh, you can rename this tutorial platform movement. Then you can look under here, void start. Okay, all this stuff is fine. If the game object.tag equals h platform or h moving platform, that means it's moving horizontally. And then this is vertically, v moving platform. Operates almost exactly like the enemy. The only thing is the velocity.y will be 0 instead of being operated by gravity. And yeah, it will just always be 0 there. And if you touch the right or you touch the left, it'll switch directions. And the same thing with up and down, above and below. It'll switch directions. And that should be good enough for how it moves. Now you need to see what happens if the player collides with the platform. So if you go into raycast detection, what you want to do is now go back to collisions, and under collisions, under ground check, we can just add some more stuff here. So if the transform dot tag dot equals player, if that's true, and the player hits hit.transform.tag.equals h moving platform or a v moving platform, essentially operating in the same way as this code right below it. The only difference is the player's the one that's deciding the collision, not the platform, because it just moves autonomously. It has nothing to do with the player. So if that happens, then you want to set the player's transform. You want him to be placed so that he's parented to this object. Okay, now that we have that, we can go back. Let's get some things in here. So platforms, let's take maybe this platform right here, duplicate it, move it down here, and then let's change its color to maybe something like a darkish blue. And we will add a tag, h moving platform, like we labeled in the script. And while we're at it, let's add the v moving platform to it. And let's go to this platform, rename it to something like horizontal, so that we remember that it's a horizontal platform and not a regular one. And tag it h moving platform, and tag it so that we can add a layer actually. We'll say moving platforms. Let me rename that. There we go. Then we can go to horizontal, put it under moving platforms. And now we're about to see some bugs. Oh, I guess I forgot a parenthesis somewhere in there. Yes. There was one more that was needed. Time to see. Okay, so we already came up with a bug before we even ran the game. But here's some crazy stuff you're about to see. So once you... Oh, don't get hit by the enemy, guys. Don't die. Okay. Oh, yeah. One thing that we haven't done yet is even add the script to it, which is ridiculous. So under tutorial, I have platform movement. Don't forget that, guys. And then maybe have the platform speed be something like 5. And make the layer mask detect platforms and players. And make the V ray count and H ray count whatever you want. Okay, saved it. Okay. There you go, another bug. Just make sure that's not really a bug, more so than just poor planning. Let me turn off gizmos so you don't see camera stuff. Okay, so right away you see that it's gone. And that's because we have a rigid body 2D, which is automatically added to the script when this script is added. So what we have to change it to is to be kinematic, and change collision detection to be continuous. And that should fix that. Okay, now that we have that, now it's working. It's hitting back and forth, and that is actually working. But now watch. The player goes, he pushes it down. That's because we actually have not added this to every possible collision. So if he's player and he hits the moving platform or the V moving platform, we want to do that for all possible directions that he might hit them from. Let's rerun that. That's strange. Oh, I know why. The player does not detect moving platforms. So you want to remember stuff like this. Let's move the player here now, just so that we don't have to continuously platform our way down, just to test this. And now he's on there, but he does have an issue. Now that he's on there, he will move with the platform because he's still parented to the platform. So when it hits the edge, he will move, and when it hits the other edge, he will move on his own. So we want to unparent him when he lands on a platform. So what we can say is that if the hit dot transform dot equals platform, right? If he collides with a platform, then transform dot set parent to null. And you could also say if the player, it has to be a player. And don't forget, just like everything else, we want to copy this and put this in all the other parts. I'm sure you can do this in a more efficient way. You could group vertical collisions and do stuff like that, but ultimately, this is just a quick and easy way to get a platformer miniseries going so that people aren't super concerned and don't understand things. So now that we have that, this should work. Oh, I didn't land or something, I guess. I don't know. This must not be tagged as a platform. That could be the reason. No, it's tagged as a platform. Let's see what happens with... Wait, actually, what if I just make it so that... Oh, I know what happened. I didn't say .tag equals. Make sure you don't make a mistake like that. Sometimes things slip when you have a big tutorial to record. So .tag, and .tag. It's okay. Things like this happen frequently in coding. So you'll probably fall infinitely if you don't do this properly. We'll get a fix for that as well soon. Then once we land here, we're unparented. We don't have to worry again. Now here's something that actually will get you really bothered. That's if we make this much bigger. This box collider is still there. Let's put the player on this moving platform. Okay. For some reason it didn't happen this time. I don't know why, but last time when I set the parent, it changed the scale. So what I had to do was I had to make the sprite as a child. I'm gonna do that anyways, just because it seems like it's jittery, and it wasn't jittery when I was trying it. So I'm gonna insert a square, which I'm gonna call sprite. So it'll be the horizontal sprite's color and stuff. That should be good. we can remove this thing, sprite renderer. Oh yeah, and then we can reset the scale of this to be like 1 by 1, and the sprite itself can be much larger like this. And remain at position 0, 0 of the horizontal thing. Then we can adjust the collider to fit the platform, but the scale should still be 1, 1. And that's exactly what is affecting things. Let's make this like 6. Player has a scale of 1. There you go. You have a working, moving platform, and it should be smooth enough that you don't have to worry. Technically, when you're in the air, you're still parented, but usually it's just so short that it doesn't matter. But if you're concerned, you can look into code for how to do it on exiting the collision, and that would require more things to do, but ultimately this is a simple solution, just gets the job done. Now let's add some polish. Let's go to our player, bring in, right click. Okay, that's not under there. Maybe it's effects. There we go. Particle system. So you can see right away it looks weird. So we can start messing with it. So looping should be on. Start delay is 0. Maybe start lifetime can be like 0.3. So just instantly is lost. So what this is that it's actually the player dust. So what we're doing is when he's moving, dust is generated so that there's like a trail and it looks good. So right now it looks terrible though. Maybe like a start speed. I guess 5 is good, but maybe 1. Okay, maybe we'll adjust that. We'll adjust that later. Size, we want to reduce a lot. So let's do a random between 2 constants, and then we go like between the size of 0.1 and 0.3. So you have different sizes like that. Start color, we want it to be slightly grayish. Start or simulation space, we don't want it local, we want it to be the world simulation, so it's within the world. And you want to make sure it plays on awake. Let's save that for now. Let's go down to renderer because I already don't like this material that we're seeing. So let's change it to sprites default. So now you'll see right away like the sprites. And then sorting mode, you can leave that alone. Okay, emission. Now we can adjust this. We don't want it to change over time, we want to change it over distance. So essentially, what we want to change over distance is maybe like change it between two constants, random between two constants. 5 to 10, we want to emit about 5 to 10 particles over a certain distance. So if we actually take this and move it around, so when you move, it'll generate particles like dust. And we can keep it at the player's feet. So currently that's fine. What I don't like is the shape that it's emitting in. It's just doing this weird cone. Let's make it a box. Okay, adjust it there. And then the Y scale we can set to 0. So it's just this little line. Now you get something that's way better. What else can we do? We can change the color over the lifetime. And what we can do is make it so that it's more transparent over time. Maybe not fully transparent, but something like that. So what happens is you have dust that like fades away. So right now it has this orange thing, and that's only because it's in the scene, but once you see it in game, it'll be a lot better. It won't have those outlines. Color over lifetime. Can do size over lifetime. And then you can adjust the size in this thing called particle system curves. So if you drag this, oh, there we go. You have to double click it, sorry. And then once you click that, you can adjust, maybe have a high size at the starting and then drop it at the end. Once you get all that, yeah, that should be good enough. And if we save this and we run this, you'll see this like dust trail. It looks like looks really good. It's just smooth. It's already feeling like a gamey game. You don't want to hit the enemies or else you respawn. So now that we've added that part of the polish, we can add some parallax backgrounds. So if you don't know where that is, I actually, in the GitHub, included within the project folder, essentially, I have it saved on my desktop, but a folder that I named parallax. So you can just drag that in to your assets folder. So once it's in, you should have 5 different objects. So what you can do is, first of all, create an empty object that you call backgrounds, and you can reset the transform so that it's centered. You don't want it to be like somewhere completely random. And then you can just bring in the 5 images. You want to do them one at a time, actually, because Unity will think that it's an animation if you bring in multiple. So you can just bring those in. And you can change their order in the layer. I believe you can just set it to the number that you see there. So 1, 2, 3, 4, and then 5. So there you go, you have some sort of background. you can change the sorting layer of these. You can add a sorting layer, like backgrounds or something. And now all of these are in the backgrounds, or actually all of these you can put to the background sorting layer. And you can make one more sorting layer that you can label player. And you want him to be visible before the background, so you can put him on that. And then platforms can all be on a different sorting layer. Actually, yeah, you can add another sorting layer, maybe platforms, and yeah, enemies. We can name this platforms here, and then we can put enemies here, and then we can put players at the top. That should be good for our sorting layers. So this is just visibility, so the backgrounds will be visible at the back. So let's set these all to the platforms layer. So backgrounds will be at the back. Player, let's put it here. And then enemies, we'll keep it on the enemies layer. And the horizontal moving platform, we didn't set that one. We'll put that on the platforms layer. That should be good. So you just play this right now. Obviously, the background is small. It's disgusting. Doesn't really show anything. So let's make the platform, or sorry, the background look better. And I'll show you why we have 5 layers. Because we're going to create something called a parallax effect. So what you can do straight away, actually let's put this back to 0, 0. And let's scale this up. Maybe 5 times by 5 times. Yeah, maybe like 3 times by 3 times. Okay, once you have that, you want to duplicate. Let's see, Control D and Control D. Duplicate it twice. And then these 5, what you want to do is you want to move them to the right by 20 times the scale. So how you do that is just do 20 times 3, which is the scale, and Unity will calculate it for you like a calculator. 60. So luckily, since I picked 3, it's just easy. It's 60 and negative 60. These you want to move to the left, so negative 60. And you have this background that's like kind of big and you can work with it. The reason you want 3 is because when you reach the edge of here, this left will move here and it will connect. And since these backgrounds are seamless, they connect perfectly. So if you ever get a parallax background, you want to make sure the edge of this side works with the left edge so that they match up. And the further you are to the background, the more blurry it is. So right away, I mean, it looks fine when you play it. Like you have a background. I mean, I personally don't like this background by itself, but ultimately it works. Like, it's there. But let's add some effects to it. Let's add something called parallax. First of all, let's move everything down by a little bit just because it's a little too high. We'll never reach the top of the level, so that the camera itself doesn't go too low or too high. Okay, now that we have that, let's put all the 1s under 1. Let's put all the 2s under 2. 3s under 3. 4s under 4. And then 5s under 5. Now we can save that, and we can go into scripts. We can make another new script, create C# script, and we're going to name this parallax. And we're just going to hop right in. We're going to add a namespace, which is CPP Game Dev Club, as usual. And in parallax, we want to serialize a field, which we're going to say private transform cam. And if we just add this right away to our backgrounds, we can just add the camera. And since we're using this virtual camera, we can just add the virtual camera to it. So we'll use player cam instead of your main cam. You can just add that to that for now. Don't worry too much yet because we haven't used it. And then we'll have like a range from 0 to 1. This will be a private float called parallax speed. So you're going to be moving the player. Sorry, not moving the player, moving the background with a certain speed so that it looks natural. Then you also want several more private floats that we don't need to see, but there'll be the length of the sprite, which we'll calculate in here, the start position, a temporary variable, and the distance. And that should be good for the variables that we need. The start method should just include the start position equals the transform dot position dot x. So it'll just take the transform dot position of each of those 5 layers, which are all pretty much the same. Then we can just add one more line which says that the length of the sprite equals, we can just get component, which is the sprite renderer. And then we can get the bounds of the sprite renderer.size.x. And that should be good for the length. Then in our void update, what we can do is we can say the distance equals the cam.position.x times the parallax speed. And then we can just say the transform.position equals a new vector 2, which will contain the start position plus the distance that we're traveling, right? And then the transform.position.y. So we're not changing the y, we're just changing the x. And if we run this with specific speeds, so 1, I believe, is the background. Yeah, 1 is the background, so it should move with the camera. Why is this? Oh, I didn't say serialize field here. So make sure you serialize the field along with the range. Now it should show up. Yeah, I'll make it 1. This will be maybe 0.9. And we'll say something like 0.8, 0.7. and then 0.6. Because the frontmost layer, you want it to move slower, because as you run fast past it, you want to actually breeze by everything as it's moving slow. And then in the background, it actually moves along with the camera almost, except just a little bit slower, except for the background. So it'll look like mountains are passing by. And now if you look at it, it's already great. Like, you have this whole effect of depth that you're traveling at a certain depth. Oh, you're falling forever. Forgot about that. Honestly, what you can do to fix this falling forever thing is just clone an enemy, remove the enemy movement script, and you can just move him and then increase the size so they insta-die upon falling. And what you can do is just make this transparent so nobody can see it. So if you fall now, you'll die. There you go. And it'll respawn. Either way, now you can see as you move, you have this nice parallax effect. But, okay. Excuse how bad I am at this game. Let's make it easier for me and move the player to like a nicer location, like right here. My point being that as you keep scrolling, you'll get to a point where you see that this background, the more and more further that you go down the level, will come closer and closer until it cuts off right here. So it won't be great. So if I just, for example, move the player camera, right now, you can see that the player has no background. Okay, let me just undo that. Yeah. Okay, so now that we have that, what we want to do is fix that issue by making temp equal to cam.position.x times 1 minus parallax speed. Because it'll check 1 minus that to see if for example, if you've moved 0.9, that means 1 minus 0.9 is 0.1. So if you move 0.9 to the right, it's like moving 0.1 to the left. So it'll move it accordingly. So that's just some math that you have to think about, but ultimately it'll work. And once you add that in, all you have to say is if your temp is greater than your start position plus the length of the sprite, right? If it's greater than that, then what you want to do is you want to set the start position to add the length of the sprite, and vice versa. If temp is less than start position minus the length of the sprite instead of plus, you want to subtract the length of the sprite from the position. And that should be all you need for the parallax to work seamlessly. So for now, let's just play and then go to the scene and watch what happens when I move the player cam. We got that working, and that is pretty much it for the platformer aspect. Now we'll do one last thing, and that is to port this over to a top-down scene. So if you haven't been interested in making a platformer this whole time, well, rest assured, because right now we're gonna do this almost instantly. So very quickly, scenes, create a new scene. There we go, scene. And we're just gonna name it top-down scene. And all we have to do is just remove gravity from everything and remove the backgrounds, because we don't really have parallax in a top-down type view. So we just Control C, go to the top-down scene, delete this main camera, Control V. We got everything here. Now all we're gonna do, go delete the camera. Oh, sorry, not delete the camera. Whoops, what did I do? Yeah, we still have the main camera. Sorry about that. Delete the backgrounds. Under platforms, we don't really need moving platforms anymore, so we're going to delete that. And we can save. We can create 3 new scripts in a folder that I'm going to name top down. Create C# script, and we're going to call this enemy movement TD for top down. We're going to do 2 more scripts just like that. Create C# script, player input TD. And then finally, we will have a player manager. And you guessed it, TD for top down. And we can just open all 3 of these. Enemy movement TD is almost a clone of enemy movement. So Control A, Control C, Control A, delete, Control V. You can say enemy movement top down. Right here, you just change this to TD. All you really change here is you remove the gravity, almost like we did with the platform movement. The only thing is that velocity.y now just equals 0 when you're moving horizontally, and when you're moving vertically, it's pretty much the same thing. So I think that actually just fixes what you need. Yeah, I think that's all you really need to change. I'm gonna leave these as enemy and flying enemy. You could actually name these tags different, like horizontal and vertical enemy, because there's no flying in a top-down world unless you have like 3D in there. And essentially, I mean, what you can do is, let me put the player all the way back here, and let me move this guy here. There's still gravity on the player, so the player is still going to operate the same. Oh, wait. One thing that I have to change is for the enemy. Where's enemy 1? Oh, that I believe is the kill screen collider or something. You can name that whatever you want. Okay, so this enemy is using enemy movement. We can remove that. And instead, we can put enemy movement TD for enemy movement top down. Give him a speed of 10 again. And this should work. So he's just going to move left and right. And essentially, it's working the same way. The top down never had to worry about gravity. But now you have to look at this as the tops of walls instead of something you land on like platforms. So these are the tops of walls, and your player should be able to move in all four directions. So right now the space is a jump, but that's actually not what we want. And we also have this dust particle effect that was cool when you had something that wasn't top down. But I'm just gonna delete this from here because we're in a different scene anyways. So whatever changes that you do here are not gonna save in the other scene. That scene's gonna work differently. So right now we don't have to worry about that dust particle again. Unless you really want that, like if that's what you're into. And then for player input top down, this is actually going to be really fun. You take player input, Control A, Control C. Take this, Control A, delete, Control V. Change this to player input top down. Now this is just deleting a bunch of stuff. So once you have this, what do you not need? Pretty much everything except velocity and health. All of these are based on the ground. Oh, and raycast detection. Need that. Gravity, fall gravity, jump velocity, allowing jumps, all that stuff is out of here. Any line that you see red, you can delete. So all of this essentially can just be removed. There's no gravity anymore. Essentially, all velocity y is going to be doing is the same as velocity.x. It's just getting input dot get axis raw. But instead of horizontal, now it's vertical. Times move speed. Because usually all four directions have the same move speed. Just move, check health, respawn. All that stuff is the same. This still operates the same, but this is based on player manager. So as soon as I bring this in, you'll see this right away, which is that since it inherits from player manager directly, what's going to happen is once you take the player and you delete player input and you put in player input TD, you'll have all these variables that you don't need at all other than move speed and max health. The rest of them literally are not relevant, so that's why we have this third script, which is player manager TD, and we're just going to take player manager, Control A, Control C, Control A, delete, Control V, and we just need the player variables. You don't need any jump adjustments, and you don't need these either. Move speed and max health. Look at that. You got your top-down manager. Oh, one last thing that I forgot to do. Two last things that I forgot to do. So it's confused now because player manager TDs, it's still labeled player manager. So we have to change that first of all. Hopefully that didn't get messed up with this. Okay, great. Now that we have that, we just go to player input TD and we have to inherit from that. That's all you have to do. Save. Go back. It should work now. Your player has just move speed and max health. Let's say 10 move speed, 1 max health. The usual. Save. So now your player is moving in a top-down perspective. These are walls, no longer are they platforms, and he collides with them completely fine. It works pretty much the exact same way, and if you get hit, it respawns. And honestly, this is way easier, as you can see, in implementation. No gravity to worry about. Now you could start building something isometric involving more complex variables like gravity, maybe having a moving platform where the moving platform is right here and there's lava underneath that, and when you jump on the moving platform you don't get hurt by the lava, but if the moving platform is not there and you went there, there would be lava or something. Kind of like Hades, but you know, we're not too concerned about that because this is 2D and not like a 3D game where you have, you know, depth to it. So that's pretty much it for this episode. We had a lot of optimizations. As you can see, we had parallax, we had a particle system, we had platform movement, we had health and death, and we implemented top-down. So thanks for watching. If you liked this video, please make sure to give us a thumbs up and subscribe. Give us any suggestions down in the comments below, and we'll try and cover them in the future videos. See you in the next one.